exponential and logarithmic functions in our last class. And we looked at the general notations for each of these. So what will happen is that these functions can both, so the same numbers index from both of these functions can be represented in two separate ways, but they are using parts of each other. So let me show you what I mean by that. So a logarithmic function, we know that this is represented as y is equal to log base a of x, while an exponential function is just x. Let me use it, since I have, so I'm going to call it x is equal to ay. And from this, the base would be the a here, and it would be the same as the a over here. So that's our base. While the exponent is the y, and it's the same y over here. So we have our base, we have our exponent, and this is just the number. The x here is just the number. So over on this side, we have the log. Over on this side, we have the exponential. So over on the left hand side here, we know that this is the logarithmic form, and we have the exponential form. Alright, so we also looked at a very unique number in relations to logarithmic or exponential functions. That particular number is, so the number is e.
Yes.
Well, the letter is e, and the number equivalent to this is what?
2.718. That's it.
718. So this e here is a constant, and its value is 2.718. So in relation to this, we have a natural exponential function. Three to the x, because this is where e falls. E lies between 2 and 3. We can agree to that, right?
Yes, sir.
So that means the exponential function for e to the x would lie between the exponential function of 2 to the x and 3 to the x. Alright, so with that said, and that's just a little recap of the general notation and what entails for the function of e. So if we see, so we also looked at some rules for logs, or some laws that governs logarithmic expressions or equations. So whenever we see something like this, log by itself, this means we're taking log to, this is simply saying we're taking it to base 10. However, when we see ln, what is the base we are referring to? So this is to base e. So these are just some important things that we need to have in the back of our heads. Alright. So we're going to be doing some simplification of logs based on the rules that you would have had. So we're going to be simplifying. So simplifying logarithmic expressions. And we'll start with an example. So we have log base 2 28x minus log base 2 7x. Alright, so somewhere in your books there is a theorem or a law that says whenever we're subtracting logs of the same base, we can treat this as division of whatever the number is here. Is that correct?
Yes, sir.
So we're subtracting logs here, so we can treat this as division of the numbers. So whatever is at the front will be treated as our numerator. So now we can write this as log base 2 of, so whatever number comes first, we treat this as the numerator. So it's 28x divided by 7x. Alright, so from here we can proceed to simplify. So 28x divided by 7x, that is 4. So now what we have is log base 2 of 4. Now some might say that this is the final answer, but this is definitely not the final answer. We can go further. So what will happen is that we can treat this 4 to satisfy one of those laws. Now there's a law that says whenever we're taking the base and the number is the same, we can cancel out the log, and that's just 1. But before we get to that point, there's something else that we need to do. So we can rewrite log base 2 of 4 to log base 2 of 2 squared. Looks weird, doesn't it?
Didn't think you could ever write it like that.
Yes, we can break apart the 4 because 4 is the same thing as 2 squared right here.
No, like I thought about it, but I was like, that looks too weird for it to be correct.
Well, it is indeed correct. Alright, so what will happen now is there's a law that says whenever we have an exponent here, we can bring it to the front. So this will result in 2 log base 2 of 2. And as stated before, so based on the law, we have the same base, same number. This part here is just 1. So what we have now is, so let me continue up here. So all of this now becomes 2 times 1, which is just 2. And this would be your final answer to this question. Is that clear?
Yes, sir.
No, sir. Can you explain how you got the 1 again?
Repeat.
Sir, I'm asking if you can explain how you got the 1.
The 1 right here.
Yes, sir.
Alright, so the law that states whenever we take a log, so there's a law, and it says whenever we're taking the log of a base, and whatever base we have here, we have a number that is the same, this will result in 1. So if you look here, we have log base 2 of 2, so that's simply 1. And this is based on one of those laws. So you should look through the laws, study them, and incorporate them with these questions. Alright, so let's look at another question. So this is example 2. We want to find or simplify log base 3 of 81. What is the approach we need to take for this one?
Sir, we'll be using the third rule where log ax equals log ay, hence, well, where x equals y.
Log ax equal log ay. No, but this isn't equal to anything.
Oh, the property, the third property that you gave us.
Remember, we're simplifying, this isn't equal to anything. So what we'll have to do is break down the 81 here. So we notice that the base is 3. We need to find what power of 3 gives us 81 and rewrite it as that. So it will be log base 3 to the 4th power, right? So now we can rewrite this as 4 log base 3 of 3, and that's just 4. Any questions on that? So no questions? Everyone is clear with that?
Yes, sir.
Alright. So I have several questions here. So I'm going to give you 2 more examples. Then I'm going to give you 3 questions to try. Alright, so this is example 3. We have log base 3 of 1 over 9. What can we do with that? There are 2 approaches we can take for this question. I want to see if you guys are thinking. How can we approach such a question? What's the first approach we can take? And what's the second approach? Not sure?
Sir, I'll give it a try. Sir, so the first rule that we could use is where we said that log base a, and when x is divided by y, it's equal to log a x minus log a y. We could do that, or we could do log a x to the power of n. So for the first one, we'd say log 3 1 minus log 3, 9. For the second one, we could say log a x would have been 3 to the power of negative 2, I'm guessing.
Yes, so both of those are correct. So now we just need to simplify.
Okay.
So that's equal to that. Is that a question for me in the chat?
No, I just raised my hand.
Go ahead.
I was experimenting, and could we do log 3, then 3 raised to 1 over 27, or is that too complicated?
Log 3.
3 and then 3 raised to 1 over 27. Because that will give you back 1 over 9.
This will give 1 over 9?
Yes, sir.
Are you sure?
Well, that's what my calculator says, you know.
Let me try mine. So 3
So,
raised to
yeah,
the...
raised to 1 over 27. Oh, okay.
My calculator not giving me that.
So why is my calculator telling me that?
The same one I told you to get rid of?
Yeah.
Alright, that explains it. Alright, so whenever we take log of 1, what's the answer for that?
0.
0. So it's 0 minus, and over here this is the same thing as 3 squared. Great. Alright, so the second approach, we converted the 1 over 9 to 3 raised to the negative 2. And as you know, the law states that we bring the negative 2 to the front. So our answer is just negative 2. And it's the same answer here, same answer here, with two different approach. So sometimes these questions will present you the opportunity of using different ways and arriving at the same answer. Alright, so let me give you one to try, or two. Simplify log log base 3 1 over Right, so I want you to give those a try. For the first one,
yeah, part A I got 1 over 3.
for the first one, I got 1 over 3.
Yes, sir.
What approach did you take for this one?
Automatically, my brain was like, I need to rewrite cube root of 10 because I didn't know how to move forward with that. So I rewrote that as log 10, because you know log is already log 10, and then 10 to 1 over 3. So then after that, I just follow the rule that you've been using where you carry over the exponent to the front, and then log base 10 is 1. So 1 over 3.
All right, very good. Deacon, you're up.
I did the same thing.
For this question over here,
the square root of 3 to 3 negative a half, and then same thing, put the negative a half on the front, and yeah, I got negative a half. For the answer.
And did everyone get negative a half?
Yes, sir.
Alright, it seems as if we need to step it up a notch. Not to worry, we'll get there in due time. Alright, so we have a special case kind of simplification. Whenever we have, so this is a special case. So whenever we have ln e raised to a particular power, this simply becomes whatever that power is, because ln cancels out the e, so ln and e cancel out each other. So these cancel out each other. So whenever we see them beside each other, just know that they're going to cancel out. For example, if we have ln e raised to the 4x plus 2, this answer would simply be 4x plus 2. If we have ln e raised to the cos x, this will just be cos x. Pretty simple, right?
So far.
It doesn't get any more complicated than that.
Don't really trust you, sir, but we'll see.
And so on and so forth. Alright, so with that said, we need to get into some solving. Solving equations. So solving log equations, and then we'll get to solving exponential equations eventually. Log equations are very nice, trust me. So solving logarithmic equations. And of course, we'll start off with an example, as per usual. Let's say we needed to solve the following equation. Log base 2 for x plus 2 is equal to 6. So if we were given such a question and we needed to solve this, what we would have to do is apply our knowledge of going from logs to exponentials, because there isn't any log rule that can help us with this as is. Well, for right now anyway, but we need to get from this log, or get this log equation to an exponential equation. And how do we do that? How do we go from a log to an exponential?
Sir, can we break that up?
No, we can't. There isn't any law that governs that.
Oh, so we rewrite it then in
Exponential
somewhere.
form.
Yeah.
So we go in a counterclockwise direction. And we will have 2 raised to the 6th power is equal to 4x plus 2, right?
Yes, sir.
And then we should be able to solve this. 2 to the 6th power, that's 64. That's equal to 4x plus 2. 64 minus 2 equals to 4x. So 4x is equal to 62. And x is equal to 15 and a half. Clear?
Yes, sir.
No, sir.
Where did I lose you?
Sir, when you put 2 raised to the 6th power equals 4x plus 2.
Yes, because this 2 right here is our base. This 6 right here is our exponent. And all of this in the bracket is just the number. All of this in the bracket is just the number. So the base raised to the exponent, so 2 raised to the 6, is equal to all of the number.
Okay, sir.
And then we just simplify, get our answer. Let's try another example. And sometimes these can end up as quadratics. So example 2. So we have log base 2 x minus, what is this, 7, x minus 7 plus log base 2 x minus 8 is equal to 1. So in this case, we can't just convert this to an exponential equation, right? Because we have 2 things over here, log of 2 different things. So we can't just say 2 to the first power equal that, 2 to the first power equal that. We can't do that. We'll have to apply a log or one of those laws before we can bring this to its exponential form. So which one of the laws do you think can be applied here?
Log base a xy.
Yes.
What is that? The fourth
So-
one, yeah.
So we're adding logs with the same base. So we can just rewrite these numbers as products of each other. So this is the same thing as log base 2. We can rewrite this as product of each other. X minus 7, x minus 8, and this is equal to 1. Is that clear?
Yes, sir.
So now we can go ahead and convert this to its exponential form by saying 2 raised to the first power is equal to all of this inside the bracket. So this will give us 2 raised to the first power is equal to x minus 7 x minus 8. Then we'll expand, get our quadratic, and then solve. Alright, so this is 2 is equal to x squared minus 15x plus 56. So we can bring over the 2 on that side to get this as a general quadratic. So x squared minus 15x plus 54 is equal to 0. So now we need to apply AC method to this. So we have negative 15 here. Two factors of 54 that will give us negative 15 when added are negative 9 and negative 6. So we have x minus 9 and x minus 6. And that's equal to 0. So don't follow me and skip this step, show your step right here. We've been doing this for some time, so we've built that experience. Right, Sign?
Yeah, for sure.
So now x is equal to 9 or x is equal to 6. And why are both of these answers acceptable? What if we had had a negative 6 here? Would that work?
No, sir.
Because if we were to put negative 6 up here, we'd get negative 13, and we can't take the log of a negative number. So just remember that. Alright, so let me give you one to try. Alright, let me give you one to try. So this is for you. Solve log base 3 Alright, so give that one a try. I'm giving you 6 minutes.
So log base 3, then I put, since we're subtracting them, we're going to put the x squared minus 9 over x plus 3 equal to 3. Then because the x squared minus 9 is the difference of squares, so we're going to factor them out. So that's going to get x minus 3 and x plus 3. Over the x plus 3 equals 3. Then we're going to cancel the x plus 3. Then we're going to leave up with log base 3 of x minus 3 equal 3. Then we have x minus 3, because of the rules, sir, with the log base y equals the thing where you have the b to the x that I use. So x minus 3 equal 3 to the third power. Yeah.
So x minus 3
is equal to 27, and then we transpose of x equal 30.
Alright, wonderful. Did everyone else arrive at this solution?
Yes, sir.
Yes, sir.
Okay, great. We're well on our way. We're well on our way. Alright, so these would be the types of questions you would encounter when solving log equations. Now, we have the counterparts solving exponential equations. So we'll be taking on a few of those, and then we'll be looking at the combination of those, where we will use which one and so on and so forth. So now, I want to look at solving exponential equations, or equations involving exponents. So equations involving exponents. That's our next subtopic. Alright, let's start with an example. So let's say we have 2 raised to the x minus 1 is equal to 9. And we needed to solve this. Now, looking at the numbers in the base position, the only way possible for us to solve this right now is if we take the natural log of both sides. So we'd have to take ln, let me write it like this, ln. Which way better? This way or the cursive way? So take ln of both sides. So now the left hand side will become ln 2 raised to the x minus 1. The right hand side ln 9. So we'll bring down the power based on the law. So x minus 1 ln 2 is equal to ln 9. So remember, we're still solving for x. So we need to get rid of this ln 2. And we can do so by dividing ln 2 on both sides. So now it becomes x minus 1 is equal to ln 9 over ln 2. So to get rid of this negative 1, we bring it across. So x is equal to ln 9 over ln 2 plus 1. And whatever you put this on your calculator and get, that will be the answer. So ln 9 divided by ln 2 plus 1. So that's 4.1699, so 4.17. So x is equal to 4.17. So is that clear? Pretty straightforward.
Sir, question, did you have stated why you use natural logs for that question like this?
That's the only way we can break it down. We can't convert this to any other. Remember, it's an exponential form, and we need to change it to a log.
Sir, but wouldn't you use ln whenever e is involved?
No, not all. You use it as well whenever e is involved. However, in this case, we have to convert it to a log. And the only way we can convert this to log is if we take the natural log of both sides.
So we couldn't use normal log to figure out this question?
Alright, let's try it. I think it should give us the same answer. But the same principles will apply, right?
Assuming so, right?
Alright, so log. So x is equal to let's find out moment of truth. So log 9 over log 2.
It gives the same thing.
Same answer?
Same answer.
Okay, wonderful. So yeah, we can use ln or log. But the general one that we use, is ln. It does. Either way, you'd still get it right. But this is just the general one that we always use. ln of both sides and so on. but as I've stated, anyone you use, it will be fine. All right, let's try one that involves e. So e to the 4x plus 1 is equal to 3. So this is example 2. Alright, so we can take ln of both sides. So 4x plus 1 ln 3, x is equal to ln 3 minus 1 over 4, and whatever answer we get, that's our answer. Because this is the answer I'm getting here, 0.025. So what we're going to do now for the rest of the session is we're going to just practice a few more questions.
Thank you.
So solve the following. Alright, so before I write the next question, how do you think we would start this one? Or are we good with it? We can just write the next question and you guys just get them done. Alright, seems as if everything is good.
No, sir. Please explain.
Alright, so for this one, what you're going to be doing is, so we have ln here, subtraction. So we're going to combine this as a fraction. So it's ln x plus 1 over x is equal to 2. So now, to get rid of this ln on this side, we'd have to take it to e. So we'd have to put e as the base, being raised to ln x plus 1 over x, right? So we can cancel out the ln. And then over here, since we take e as the base over here, we have to say e squared over on this side. And then we just evaluate and get our answer.
Sir, you're gonna have to write that over for me to see.
So this is going to be ln x plus 1 over x is equal to 2, right?
Yes, sir.
So now we take e as the base on both sides, so we can cancel out the ln on this side. That's going to just leave us with x plus 1 over x is equal to e squared, and we're supposed to be able to finish this up.
Okay, thank you, sir.
So I'll leave that space there. So for those of you who know me, whenever I write questions and I put a red asterisk beside one of those questions, it means that that question is a tough question, or it's going to require a little bit more from you. Maybe it will even require something that you haven't been taught as yet. So question 4 might be what we start off tomorrow's session with. So just finish up question 1, 2, and 3. If you can attempt question 4, feel free to do so. So I'm giving you, so you should almost be finished with question 1 by now. So another 10 minutes should get us there. Johnstone?
No, sir, I'm not finished yet.
Alright, so walk me through question 1. How finish up this one? What do we do here?
Well, you could transpose, I think.
So x plus 1 what next?
And then, well, what I did was that I put all the x's like on the same side.
Then
Wait, sir, couldn't you just divide the x plus 1 by the x and have e squared on one side? Like,
divide x. That would get us back to the same thing. So we can factor out the x. Let's see what this gives us.
Sir Deacon has a question.
Go ahead, Deacon.
sir, I'm looking if you could do it the other way, like don't move the 1 over the other side and put the negative 1, but like leave it as a positive 1 and move the x instead.
But it will give us the same thing. Regardless of which side we transpose, it will give you the same thing.
Alright, sir, can you do it, please?
So if we transpose the x, we'd have 1 is equal to x minus x, factor out x, so 1 over, and it's the same 0.157 regardless of which way we transpose. Make sense?
Yes, sir.
Alright, so question 2 now. Who finished this one? Jay, shall you finish this one?
Sir, you use the quadratic for finish the last part. I me a bit.
Alright, so we need to rewrite this. So this will be log base 2 of x squared so now we can combine this as a division.
Sir, 1 plus root 3.
Yes. Any other answer?
Sir, I have 1 minus root 3, but I can't use.
Why can't it be used?
Because you can log a negative.
That's going to give us a negative, and we can't have the.
Log a negative number.
But did you test it back in the question to see if it will work? Because you'd have to test it back in the question, you know, to see if whenever you put it as the x here, does it result in a negative number after we square it and all of that. So that's the thing we have to test before we say it's a negative number, so we can't take the log of it. Then for this we apply quadratic formula.
Sir, I tried it and it said error.
Oh, it gave error.
Yes, sir.
Okay. So this is 2 plus minus square root b squared. So that's 4 minus -8. So 1 plus root 3 would be the only valid answer. Alright, good. So is everyone clear with that one? So what we did there?
Sir, could you explain how you have 2 to the first power is equal to x squared over x plus 1?
Same concept. We have a log here and we want to change it to its exponential form. So 2 to that power is equal to all of this.
Oh, okay.
And then we just expand, we just cross multiply, get our quadratic formula, test the solution to see if it works, and that's it. Alright, so last question and then we'll wrap up. Did anyone manage to finish this one?
Yes, sir.
What did you get?
I wasn't sure if I was supposed to plug this into the calculator, but I got x is equal to ln 5 divided by 2 over ln 2 plus 2 ln 5.
So what's the decimal answer?
Is it because I apparently have a faulty calculator? I never bothered to put that in there. So I was gonna wait to see what your calculator says.
Okay, so we take ln of both sides. Then we apply the law. So we can evaluate what ln2 is, evaluate what ln5 is. Or we can distribute. So x ln2, ln2, ln5 minus 2x ln5. So we can simplify from there, or we can work it as is and then simplify after. But I'm going to simplify first. So ln2 is 0.69. So 0.69x plus 0.69 is equal to ln5 is 1.61. So this is 3.22. Then we group the x terms on one side. So 0.69x plus 3.22x is equal to 1.61 minus 0.69. So this is 3.91x is equal to 0.92. So divide by 3.91, and x is equal to 0.24.